Hi, so in the previous video we found the actual values of certain variables on balanced growth path in the Solow growth model, and in this video, as we hinted at in the previous video, we want to know the savings rate which gives us the highest possible consumption once we are in the balanced growth path. Now, so effectively this just means we're going to maximize our consumption, and in the previous video we showed that this consumption tilde is equal to this expression, and it's in terms of the savings rate and the other parameters in our model, and we are going to maximize consumption with respect to the savings rate, because we say that this savings rate S can be changed by policymakers. There could be some sort of policy added to this economy that could increase or decrease the savings rate, and so we want to know which of these S's maximizes consumptions. Then policymakers can aim for this savings rate because we want the highest possible consumption as consumers and individuals in the economy gain utility from consumption. So higher consumption is always better. This is what we value our economic welfare on. So if we are maximizing this term with respect to savings, well, we're going to take a first order condition with respect to it. So we differentiate this term with respect to S, the savings rate. But we notice that S appears in this 1 minus S term, and it also appears in our S over sigma, or S plus delta plus N plus G. So it's going to be a little bit tricky to differentiate. We're going to have to use the product rule, which says that if we want to differentiate, say, a product of two things, let's say it's the product of UV, well, this is going to be equal to the derivative of U multiplied by V plus the derivative of V multiplied by U. And that's what we've done here. And so I won't go through exactly what we've done, but we've effectively taken the derivative with respect to S of this bracket, and that has just come out as -1, and then multiplied this term here, and then taken the derivative of this term and multiplied it by 1 minus S. So just use the product rule. Obviously the derivative of this big term is a bit tricky, so I won't go through it, but we drop down this power and we take the derivative of what's inside the brackets and so on. So we get this complicated expression, and it's a first order condition, so we set that equal to 0 as we're finding the optimum. And what we can do is take out as a factor this S over delta plus N plus G to the power of alpha over 1 minus alpha, and we are left in brackets with this term here, and this is still equal to 0, of course, because this is a first order condition and we haven't moved anything to the other side of the equation. So what we can now do with this is just divide through by this S over delta plus N plus G term, also raised to the power, and we can do this because we know that this is not 0, so we can divide by it, and it's obviously not 0 because we know that these parameter values, S is some positive value, and so we're left with this simpler expression. And maybe I've overdone the workings on solving the remainder of this, but we can add the 1 across, and then we can multiply across this S and divide across this 1 minus S, so we get this expression here, that S over 1 minus S equal to alpha over 1 minus alpha, and then just by inspecting this we can see that these sides, or both sides of this equation, are just equivalent, but we just have this alpha and S, and so just by inspection we can see that S must be equal to alpha, and so this S equal to alpha, this is our golden rule savings rate. S has to be equal to alpha. What is alpha? Well, this is the capital share of income in our economy. We know that our production function, we define it to be K alpha multiplied by AL to the 1 minus alpha, so alpha is just simply our capital share of income, as we know from Cobb-Douglas technologies and from just the neoclassical production functions that we've looked at a lot. So this says that the government should be aiming for, once it's a balanced growth path, it should be aiming for the savings rate equal to this alpha. And we have looked at the golden rule in the previous videos when we were just looking at golden rule steady states. This is a very special case of this because it's the golden rule of the unique balanced growth path. But let's say that we currently have our S, which is above this savings rate, which is the golden rule, so we'll superscript it with GR. And if S is above the golden rule steady state, then our economy is dynamically inefficient. Dynamically inefficient. My pen is not working very well, so that is terrible handwriting. But it's dynamically inefficient because our savings rate is currently above the golden rule, so we could decrease this savings rate and then move closer to the golden rule. And if we decrease our savings rate, well, in the short run, this is going to mean that we increase our consumption, because we know that our output is just a function of consumption and investment. So if we decrease our savings rate, it's going to increase our consumption in the short run. So in every period, we're just going to increase our consumption, and it's also going to increase our consumption in the long run, because that's what this golden rule savings rate says. It tells us what our long run consumption is, and so this is maximized at this savings rate alpha. So we're dynamically inefficient if we're above this golden rule steady state, because by decreasing our savings rate, we increase our consumption in every period. If, however, we have our savings rate is currently below the golden rule steady state, well, to move towards the golden rule, we'd have to increase the savings rate to move closer to the golden rule savings rate, and this will mean that our short run consumption is going to have to fall because we're saving more of our current consumption, and so that's going to have to fall in order to increase our consumption in the long run. So we have a sacrifice that has to be made there in order to increase future income and future consumption. So this economy is thus not dynamically inefficient, not DI, dynamically inefficient. So that's the golden rule steady state in the balanced growth path of the Solow growth model. If this was at all useful, please drop a like, check out the playlist for future videos on the Solow growth model, and subscribe for lots more videos.